This is going to be quite a simple project to pimp up my desk. Basically, I've had to rejig my desk environment and move to a standing desk. I needed a little bit more light around the desk as it was just a little bit on the dark side. So using some of the equipment I had around, I built a control under the desk lighting system. I didn't want to spend a lot of time on the project, well, not immediately anyway. It's a sort of project that I might come back to and enhance as we go. So I've constrained this to components I had on hand and approaches I've used on other projects. Too much hunching over a desk has unfortunately caught up with me. Back and neck pain have slowed me down just recently. To help with this, I'm moving to a standing desk, moving between sitting and standing through the day. This means I have had to move away from my shelving unit and its under-shelf lights, leaving my desk a bit dark. With a standing desk conversion, I'm also lost a lot of desk space, so I didn't want to add desk lights, taking up the little space I have. I have some WS2812B LED strips left over from my lightsaber wall light project. These ones are 60 LEDs per metre, rather than the 144 LEDs per metre I use for the lightsaber project. Of course, I have some Picos too. You may remember I designed a PCB a while ago for a video turntable controller. This included the little electronics to drive WS2812B LEDs at 5 volts. It also included some switches and a rotary encoder for input, which is exactly what I need for this little project. This video is sponsored by PCBWay, who helped me out with the manufacture of the PCB for this project and some of my other projects. PCBWay are a friendly manufacturer of PCBs, 3D printing, CNC, sheet metal fabrication and injection moulding. Everything I need from a partner in my builds. I'm going to use WS2812B LEDs for the illumination. Now I'm going to cut this up into sections and then use connectors to work my way around the desk. I was going to just use the adhesive from the back of the LEDs to stick it, but actually I found that really didn't hold, so I ended up actually having to use hot melt from a glue gun. I'm using quite a lot of LEDs in this project, 145 in a string, so I really do need a 5 volts signal to drive it, rather than trying to put it off of 3.3 volts. To generate the 5 volt signal, I'm going to use a 7400 series logic to push up from the 3.3 volt output logic from the Pico up to a 5 volt logic to actually drive the LEDs. We then have some single pole single throw switches which were used to drive presets, and a rotary encoder that I could use to actually dim or select a particular colour. So the circuit board I'm going to use is actually the circuit we've used before. I used it on the video turntable. I don't need a couple of the components. I'm not going to drive a stepper motor from it, nor am I actually going to use a Hall effect sensor to detect the position of the stepper motor. So it's really just simplifying this down a bit and only using some of the parts of it. We have the input switches, which are just a bank of 4 single pole single throw switches which are all pulled to ground. Then we've got a rotary encoder with a couple of capacitors just to smooth it out a little bit, and that's connected in there as well. And I've put an LED so that I can just have a pulse LED to know that the board is on and everything is working okay. The WS2812B side of the circuit is really quite a lot about power and maintaining power to the board. So there's a large capacitor there just to stop us browning out the Pico when we go from all off to all on the LEDs. Then we've got the 7400 NOR gate, which we're using to drive a signal into the WS2812B LEDs at 5 volts. So the PCB I'm using here is one that I've used previously from the video turntable, and it was made for me by our sponsor PCBWay. This was a doddle to then solder up and place the components on it, all ready for us to actually write some software. The software for this project is very straightforward. I've written this all in C++ using the Pico SDK. I use C++ rather than just C, so I can encapsulate the design into objects. This helps me speed up my development. The rotary encoder is a noisy device and best handled through sampling at a specific polling rate. I've chosen to use FreeRTOS as that makes this easy for me. I don't need to then worry about the sampling loop clashing with other parts of my code. I've used Forsaken NGS's Pico LED library to drive the WS2812 LEDs. The technique I've used in the code are covered in a couple of courses on Udemy. My Raspberry Pi Pico microprojects course covers the WS2812B LEDs, switches and rotary encoders. My FreeRTOS course for the Pico shows how to use multitasking on the Pico and communicate between these tasks. I'll put some limited time voucher codes for both these courses into the description. I've placed all of the source code repos on GitHub. More about the hardware and PCB schematic can be found on my video on the video turntable. I'll put a link to that in the description too. So I'm just going to cycle through a few presets. You can see the general glow under the desk is changing colour, but I'm keeping a white light on my keyboard. This was quite an easy project and a necessary one to set up my new desk environment. I do want to extend it a bit to have lights on the wall behind the monitors. That will wait for another day though. How else would you extend the project? Do you think I should include IoT and let the lights notify me of events? I'd love to hear your thoughts in the comments. I hope you enjoyed the video. Please do click like if you did, as it helps others find the video and it motivates me to keep making these videos. Please subscribe to see what I will do next, and goodbye for now.